We never get bored talking about Mars missions, even though there are too many past and present missions to Mars. But still, they never fail to surprise us with something exciting and new. Today we're going to talk about the latest NASA mission to Mars, the Mars Perseverance mission. Let's get to it. The reason we see so many missions to Mars, especially from NASA, is because the space agency has its own dedicated Mars exploration program to better understand Mars, and the Perseverance mission is the latest one so far, following on the works of many missions before it. Let's first discuss the interesting name of the rover. Where did such a powerful name come from, and what does it mean? The whole story begins when NASA announced a contest called Name the Rover, where school students got to submit proposals of suggested names for the spacecraft's rover. Thousands of proposals were submitted, and the public chose the submission of Alexander Mather, an 8th grade student from Virginia Middle School, who suggested the name Perseverance. Thomas Zurbuchen, the Associate Administrator of the Science Mission Directorate, said the following public statement about the name Perseverance. Alex and his classmates are the Artemis generation, and they're going to be taking the next steps into space that lead to Mars. That inspiring work will always require perseverance. We can't wait to see that nameplate on Mars. So the mission will indeed need perseverance, and just like its powerful name, the mission also has some powerful goals to achieve on the Red Planet. 4 main scientific goals will be sought by Perseverance. The first, looking for signs of past life on Mars, and that's through studying biological signatures in the Martian rocks that may lead to the discovery of past microbial lives. The second, characterization of the Martian climate. Through that goal, Perseverance will study the climate to search for ancient environments where past microbial lives could have existed. The third, characterization of the Martian geology. By working on this goal, the rover will study layers of rocks on the Martian surface to better understand the geological processes of Mars and the formation of its surface. And the long-term and final goal is to prepare for human exploitation. This goal has to do with NASA's plan to send humans to the Red Planet in the future as part of the Artemis program in the 2030s. And such a great trip must follow tiny steps of preparation to live on Mars. These steps of preparation include Perseverance demonstrating different technologies for life support and production of fuel that could be used in the future by astronauts on Mars. The rover Perseverance is also famous for being the first rover that will collect samples of Martian soil and rocks to be sent back to Earth for analysis. Each sample will be about 15 grams, half an ounce in weight. The process is called sample caching, and it's not a trivial one. It consists of 3 steps only to collect the samples and leave them on the Martian surface. The first step is collecting the samples. The rover is equipped with a robotic arm and a driller to drill up to 5 centimeters or 2 inches under a targeted rock on Mars that the science team has chosen for being a candidate for supporting past microbial life. The rover is then going to collect samples in 43 sampling tubes, and another robotic arm is going to store the tubes in the rover awaiting the next step. The second step is storing on board. In this step, the sampling tubes are in the rover to get sealed until further instructions from the science team on where to deposit them on the Martian surface. The third and final step is depositing the samples on the surface. By now, the science team on Earth has chosen 1 or more locations for the sampling tubes to be deposited. These locations will be known as Sample Cache Depot and are chosen based on landmarks on the Martian surface and coordinates from orbital measurements. After Perseverance has deposited the samples on the surface of Mars, another 2026 NASA mission called Sample Retrieval Lander will deliver a rover that belongs to the European Space Agency ESA. This rover is supposed to reach Mars and pick the samples up and prepare them for yet another later ESA mission called Earth Return Orbiter to bring the samples back to Earth. Now let's talk a little bit about the structure of the rover and the science equipment that will allow it to perform all the scientific goals we mentioned. Perseverance is a 6-wheel rover. Each wheel has its own motor, but only the front 2 and the rear 2 have steering motors to enable the rover to curve and turn around. The brain of the rover is a 200 MHz processor, and the rover has 2 of them in case one was faulted or damaged. It also has a flash memory with a storage of 2 GB. Both the memory and the processor are not the conventional type you would find in your computer, because on Mars the radiation is much greater than on Earth, so the processor and memory on Perseverance must be fabricated specially to withstand the radiation on Mars. One more detail to note about the rover is its new and sophisticated robotic arm. The rover needs to be able to drill and collect samples from the surface of Mars, and to do that job it needs a special robotic arm. The robotic arm on board Perseverance is 2.1 meters long, 7 feet, and it has 5 degrees of freedom to allow movement much like the human arm. At the end of the arm, there's its hand, or turret as NASA calls it. This hand hosts some scientific instruments, including a 27mm or 1-inch drill that will be responsible for extracting samples from the Martian surface. Now, it wouldn't be a scientific mission without scientific instruments. Perseverance carries 7 instruments that will allow for great science on the Martian surface. Mastcam-Z, a camera mounted on the rover at the eye level, and will be used to take images and videos of the Martian surface and atmosphere. The camera can also zoom in distant objects, and it has a resolution between 0.15mm, 0.0059 inch per pixel, to 7.4mm, 0.3 inches per pixel. META. It's a suite of 6 different sensors that perform a full weather analysis on Mars. They measure everything related to the weather, from the temperature to the humidity to the direction and speed of wind. It also gathers information on the radiation and dust particles in the Martian atmosphere. MOXIE, which is a prototype of an experiment to showcase the possibility of oxygen production from carbon dioxide in Mars's atmosphere. Operating this equipment is important because the same technology will be used by future astronauts on Mars for fuel and breathing. PIXL. This instrument is an X-ray spectrometer that is able to identify chemical composition of rocks. It also has a camera that can take very fine details. The instrument is mounted on the hand of the robotic arm. RIMFAX. This is a ground-penetrating radar imager that is used to see under the surface. This instrument is particularly useful in studying the Martian geological features. Sherlock. Named after the famous fictional character Sherlock Holmes, this instrument consists of a spectrometer, a laser, and a camera called Watson. Yes, named after Sherlock's partner, Dr. John Watson. This instrument will search for signs of past microbial life on Mars by studying the minerals and organic material on the planet. SuperCam. This instrument also consists of a spectrometer, a laser, and a camera, and it can study objects as far as 7 meters or 20 feet. The SuperCam will be used on an atomic and molecular level to study the composition of soil and rocks. It will also search for organic traces on Mars that might be linked to past life. All these scientific instruments will perform science on the surface of Mars, but actually the science will begin much earlier. It will begin exactly at the same moment the spacecraft begins entering the Martian atmosphere. The spacecraft is equipped with different sensors to collect data during entry, descent, and landing. The Medley 2 suite of sensors will measure the temperature and the pressure on the heat shield, as well as the afterbody. Gathering data during the entry, descent, and landing is as crucial as the science done on the surface of Mars, and that's because it allows engineers and mission designers to get feedback on their work and to design better missions in the future. The spacecraft also has some cameras and a microphone dedicated specifically to capture the moments of entry, descent, and landing onto the Red Planet. But the spacecraft of this mission does not only carry the rover Perseverance, it also houses the entry, descent, and landing system that will help the rover enter the Martian atmosphere and descend and finally land on the surface. The same method of entry, descent, and landing has been used before on another Mars rover, Curiosity. During this method, and once the spacecraft reaches the Martian atmosphere, it will photograph and scan the ground beneath it, looking for a candidate landing site that is also close to the desired target landing site, where scientific experiments are to take place. Once a landing site has been chosen, the spacecraft will use a new technology called range trigger to measure the exact time to deploy its parachute so that it wouldn't miss the target landing site. This way, the mission team makes sure the spacecraft doesn't land on a random site and wouldn't have to spend precious time and power moving to the desired landing site. On descending, the spacecraft will have to know if the landing site it's headed towards is safe or full of rocks and hazardous slopes. And that's where this next new technology comes in. The Perseverance mission team has come up with the new Terrain Relative Navigation System to help the spacecraft land safely on the red planet. This new system works during descent by allowing the spacecraft to create a map of the surface it's landing on and compare it to the onboard stored map. This system can help the spacecraft reorganize hazardous terrain up to 300 meters, 985 feet across, and if that's the case, the spacecraft can divert to another, safer surface. The new Terrain Relative Navigation System will also improve the entry, descent, and landing method in another way, regarding the spacecraft's landing position estimation. With the previous descent system, the spacecraft could estimate its landing position relative to the ground with an error of up to 2 to 3 kilometers, 1.2 to 1.8 miles. The Terrain Relative Navigation System, however, will estimate the landing position with an accuracy of 60 meters or 200 feet or less. Up until now, Perseverance is planned to launch on July 30th, with a launch window extending until August 15th. The July-August launch window is not chosen by luck. In fact, this window is critical in the launch process, because in the months of July and August, Mars and Earth are closer to each other than any other time during the year, which means less power is needed to reach the red planet, and in turn less fuel and less overall weight. The spacecraft will launch from the launch pad Complex 41 at Cape Canaveral Air Force Station in Florida aboard the famous Atlas V 541 rocket. The Atlas V rockets are known for launching a lot of past science missions into space, like the New Horizons spacecraft and Curiosity rover, among others. If no delays were to occur, the red planet will welcome the landing of Perseverance on February 18, 2021 at Jezero Crater and perform scientific experiments for approximately 2 years, the equivalent of 1 Mars year, with the intent of expanding the lifetime of the mission in the future.